Hi everyone, Julian from Digital Pebble. So this is an updated version of the tutorial on StormCrawler and Elasticsearch. So I'll show you how to do a basic setup for a StormCrawler topology with the resources and everything, and how to plug Elasticsearch, how to use Kibana to display the results, and so on. So there was a previous version of this tutorial based on Elasticsearch 2. So this one is a little bit more up to date. It's Elasticsearch 5.3. Right, let's get started. So let's build a, let's use the archetype. So what the archetype does is that it gives us a good starting point for a topology with StormCrawler. So let's define a group ID. So we'll call that demo artifact. So you can put any value you want here. It doesn't really matter. So if I go into tutorial and I'll display the content. So this has created a few things for us automatically. And here we already have a working topology. So there's a topology class which defines the basic components like the fetcher, the parsers, and so on. And there's an equivalent in Flux, which is a nice language for Storm, where you can do exactly the same thing but through a configuration file. So there's nothing to compile, and it's quite nice. We also get a configuration file here with those things we want for our components and how we want them to behave, and also the like agent name and so on. So we'll change that because we're not anonymous code. We are so it's a bit silly, but in practice you would put your some proper contact stuff, and I'll be super honest. I'll say it's me, right? So that people can contact us if needed. Right. So that's our basic configuration. We have README, which tells us how to do all these things. So how to build it and so on. And the beautiful thing is that it's already created a pump file for us with all the dependencies it needs from StormCrawler and so on. So we said we wanted to use Elasticsearch for three things actually. To store the status of the URLs we're fetching. So a little bit like the CrawlDB in Nudge. For the ones of you who are familiar with Nudge, that's a CrawlDB equivalent. We also want to store metrics. So there's an absolutely terrific way in Storm of generating new metrics and everything. So we have resources in the Elasticsearch module to send that to an ES index, and then we can use Kibana or Grafana to display the metrics. We'll see that a bit later. And finally, we also want an index to store the content of the document, so that we can run some searches against the textual content of those documents. So we need Elasticsearch, obviously. So I have version 5.4 here, but it works with 5.3. And we have Kibana installed as well. And I'll just check that we have. Nope, we do not have Storm. I will start them straight away. Ah, of course. It can't find Storm. Not a problem. We can do well, we can do that manually. So it's probably because I have changed the location of Storm. So we'll have Storm 103 here, not a problem. So we can spin the services by hand. So we can do I'll do that in a separate thing. So we can spin a Nimbus service. Oh, that was clever. So yeah, this is live, and I'll probably not edit this thing, so apologies for any stuttering, hesitations, fake French accent or anything, but it's better than nothing. So here it's launching Nimbus, and then we'll launch a supervisor. So here it's a single node, it's just my old desktop. So it's done Nimbus, supervisor, and UI. Hello, so we should be able to see, and I'll send that somewhere else. We should be able to see the Storm UI. Yes, beautiful, great. So it works with 103, works with 110 as well. So we have all the blocks. Now let's have a look at the so what do we get from the Elasticsearch module? So I mentioned the three sort of indices we want to generate. So we could take these as a starting point. So what do we have here? We have a script that will initialize those indices. So let's have a look. So delete any existing indices, create a status index with the right mapping, defines a template for the metrics, and finally an index called index. That's very inspired with some very basic fields. So that's all good. So that lives in ES index init .sh. So we'll copy this file. We also need, what could we use? We'll use the Kibana templates later on, and we'll need a configuration file and probably the two Flux files here. Great, so I actually have all this in my in StormCrawler already, so I'll just copy the stuff I need. So I'll copy the Kibana templates, the configuration, the Flux definition, the init script, the injector, and that should be it. So I'll copy those and I'll put them here in my tutorial thing. Great. Now I have a few more things. I don't need the crawler Flux definition anymore. I can check this. And I don't need, I will need some seeds to work with. So I have those seeds. It's the top 1000 domain from last year. Here we go. So what do we have here? We have a few more things. So we can have a look at the injector Flux. So this is a very simple topology that reads from a file. So the file is called seeds.txt. So let's rewrite this little chap here into seeds.txt, and it just reads them and sends them to a component that writes to Elasticsearch, and then that will populate the Elasticsearch index. All good. We can have a look as well at the main crawler topology. So that this reads from Elasticsearch and fetches, parses, indexes, and then updates its status index. So we probably want we have 10, as we saw in the init script, we have 10 shards. So we want to make the crawler efficient, well, as efficient as possible. So we could use 10 instances of the spout. So this way we'll get nice parallelism, and things will run quite smoothly. Okay, so first let's instantiate this index of ours. So it's created 3 indices. So that's all good. We need to add a dependency. We need to add the StormCrawler Elasticsearch dependency, because here all we have is a Flux file. So we want to leverage all these components. So that's why we need the POM dependency. Right, let's build this baby. So while it does this, we can have a look at Kibana. So we'll need to define first, tell Kibana that what indices we have. So there's a status one. It's found it, which does not contain time-based events. Although we could have used the next fetch date for that. There'll be a metrics index. Because this one hasn't been created yet, it's a template. Never mind, we'll get back to this one later. And then there is the index. So we'll create the matrix in a minute. Okay, all good. Now, has it finished? Yes, it has. Great. So, yeah, it knows where Storm lives. Right. The beautiful thing about this README is that it does it with exactly with the name of your of the jar and so on. So we want to use Flux really. I mean, there's nothing wrong with the basic crawl topology, but yeah, it doesn't use Elasticsearch or anything. Whereas we have our ES injector Flux thing. So let's do Storm distributed, well, Storm in local mode actually. Because yeah, we can just use that file locally. It's not called crawler flux anymore, it's called ES injector flux, and we'll just put a arbitrary value here, which is just the time. So with flux in local mode, it just runs for a specific number of seconds, so we gave it just over a minute here. Should be enough. Let's keep our fingers crossed and see what happens. So it's loading the it's loaded the oh bang. My fault. You know what? Yeah, as I forgot that I was using Storm 103. So I'll pause this lovely tutorial for a second. I'll just spin Storm with 110, because that's one of the contributions I recently made to Storm itself, is to update some of the dependencies. So leave it with me. I'll be back with the right version of Storm. Right. I'm back. Sorry about that. I fixed the so now we have 110, and completely silly of me, because yeah, you need 110 in order to use Elasticsearch because of dependencies that we were added to Storm in the meantime. So we can now try our injection again. So it will read those URLs we had in the seeds file, and Oh, what now? This is such fun. Yes. Well, I think I know what the problem is. So it's just okay. Right, let's just use a brutal solution to this. So plus write, so everyone can write on Varlog Storm. As a matter of fact, for the injection and even for the main crawl, we don't. We could just use it in not even using Storm, just using the Maven Java exec command. But again, the assumption here is that you will have installed Storm correctly. So you can see here the bulk response, the status update of bolt. That means that it has written 100 URLs now 4 times to Elasticsearch. It's taking a bit of time. There's nothing unusual about that. It's just the settings of the topology, so it could be made a lot faster. It's not really a problem. It's just that those settings work fine for the crawl topology, not so much for the injection. But again, no big deal. And here we saw the we're running the injection as a separate step. I mean, we could definitely have that within the same the main topology as well. We could have. It's just a matter of adding another spout. That spout would just read from a file in the same way as we just did. So yeah, there's no reason why that wouldn't work. I've had users connecting while having like a simple queue with RabbitMQ alongside the Storm status update. The spout bolt spout, so that you could read from the Storm index, status index, and at the same time just add anything found in the queue straight to that index, which is a nice combination. Right, so it committed harakiri because it's been running for more than a minute. So let's have a look at the it's a good time to have a look at the status index. Yep, I got the. So yeah, we do have 1,000 URLs in there. They are so you could inject straight on the command line, but the reason we don't do that is because we generate the idea for the document with I think it's a SHA something. So doing that on the command line would be working out what that value would be a pain, and the code in the status updatable does that for you. And also it does the sharding. So we group. We remember that script. We define 10 shards. So we want to make sure that all the URLs belonging to the same domain or the same host are located in the same shard. This way we can control at the spout level. Each spout will be responsible for a particular shard, and we can control the number of URLs for a particular host or domain. And it's a way of enforcing politeness and also make the crawler efficient at the same time. Great, we have can have a quick look at the Kibana. Well, there won't be anything in here. Yeah, let's refresh. Yeah, we have. You see, so it keeps the host name because we'll be using that for aggregations. Great. So let's start the proper topology now. So it's pretty much the same, except slightly different Flux file, no sleep, and this time we'll run it in remote mode. So it will send it to Nimbus. So the previous run, it was just doing everything locally, still relying on the Storm setup for storing the logs and stuff. And yeah, we send that to Nimbus. So now if I go on that Storm UI, we'll see our crawler up and running. So it's a good practice to use, if you want, even if you have just one machine, just use the Storm UI, don't use the local mode, or just use the local mode just if you want to check something and do some debugging. And here you can see the breakdown per all the different components of our topology. And we can spot, so as soon as it gets some values, you can spot bottlenecks and stuff. So that's the old status. Yeah, there isn't very much happening. This is interesting. So in the meantime, let's see if we can add that metrics index. Yeah, ping timestamp. Great, so we've created that. So we're one step closer. Anything here? Nope. Gosh, this is turning into a drama, this tutorial. But it's good because now I can show you where the logs are. Well, it hasn't created any logs at all. Let's see if there's anything interesting in the supervisor. Okay, well, it's complaining about not being able to create that directory. Apologies, it's my dodgy. So we have the workers artifact. All right, it's because it was created under the my username. So never mind. Let's do. Let's except it's not executed. It's right. I want. Okay, let's be dirty, but that will do. So let's kill this topology. Reload this thing. It's dead. Good. Long live the topology. Now let's do let's start again. But these are the sort of problems you might encounter in real life, so in a way it's good that you see me being embarrassed with them instead of you being annoyed with it later on. Okay, that's better. Let's see. Right, so this time it's working. You can see this, it's already discovered 22,000, yeah, 32,000 URLs. And we can see, hopefully, yes, the breakdown for each component, the execute latency and everything. So it's a good way of spotting bottlenecks. Again, here we won't go into fine-tuning in this tutorial, but it's a useful tool to have, this UI. You can also check one thing I really like. You can check the if you're not really sure of what you had in your configuration. So you say, I have one fetcher bolt instance, but how many threads do I have again? So yeah, you can check your values here. Good. Now Kibana. So let's load. So we have our 3 indices. Let's load. Let's import dashboards. No, you're not supposed to see that. So let's have the let's start with the metrics, and then we'll import the status. So these are very useful tools. So let's start with the metrics. So this is a sort of preset sort of dashy with all the stuff you might need. So it's showing us the pages fetched. So we're doing like roughly 1,000, more than 1,000 per 30 seconds. So it's 2,000 in a minute, which is decent given the circumstances. Bang, bang, bang. We can see that our 50 threads, they're all busy, they're all working really hard. It's good. That bit was probably the and we can see average bytes per second, so on number of URLs waiting in the queues. So that's good. This one, don't know why this one's here. It should be up there. Never mind. That's a good monitoring tool. And now the status. So that's a good way of keeping track of what is in your index. Well, it's similar in a way to what you have with Notch when you do the stats on the CrawlDB, except that this is in real time and you can refine it as you want. So, for instance, I see, oh, what's that site? It has almost 8,000. Does it still have 8,000? Yeah, it still has 8,000. Let's have a closer look. Well, we fetched 3 and we've discovered loads. Let's have a look at the ones we fetched. Bang, bang, bang. So then you just spin those filters, and then when you go and discover, you change your index to status. That's the one you want, really. And then you can see the details of those URLs that you fetched. Yeah, that your warning sign means, yeah, it's not a field. That's a field that was created dynamically, so it wasn't in our mapping in the scripts that created the indices. So no big deal. You want a fresh view? No problem. Let's do that. So now if I go back into Discover, it should be happy about, yeah. So it's telling us the status, all the information we know about that URL. Also by default, it keeps track of the path. So you can see exactly how you got to that particular URL. And then you could remove this one, see all the ones that have been fetched. Or not even the ones fetched, you could have a look at the so per status. So yeah, most of them are discovered. We knew that. You can look at the fetch errors or the errors. Let's have a look at the errors. What could they be? Yeah, so if I look at calls, yeah, a lot of them are about robots.txt. It's just we're trying to fetch stuff, and robot says nope, and because StormCrawler is polite, it won't even try. So it's good. What else? What sort of errors are we getting? Well, that's a simple one. It's an easy one. This one. It's simply that we have documents which are not HTML documents. We have RSS feeds, we have PDF documents, we have, oh my goodness, there's even a sitemap. There's all sorts of things. And in this very simple topology, we don't have the resources for for those. So one option is to use, we have a module which uses Apache Tika, and that can be used for processing the PDFs and stuff, but yeah, it's just a demo, so yeah, we don't really care about these things. Right, so then you can use that, you can use those dashboards to go a bit deeper into the your indices and know what's happening with them. If we go back to our metrics, yeah, you can see now we are just going nicely at like 1314 per 30 seconds, which is fine. It's just small, just a demo. So that's a good tool. I tend to use Grafana as well. I don't have it on this machine, but it's a very good tool. It's beautiful at displaying things and can do things a bit different. But Kibana is very good when you want to go deep into your status index, and having that ability to, at any scale to go into the results and drill is fab. And that's a big difference with Notch, for instance. So yeah, I think we've covered everything. Let's have a quick look at the Storm UI again. Yeah, so it's all running smoothly, all good. You can visualize the stuff if we wanted to. Yeah, so it's busy parsing. We could add a few more tasks to the parser, but it's nowhere near capacity. It's at half capacity, so even if we are fetching twice as many documents, we'd still be all right. So yes, that's it. So that was a slightly chaotic but hopefully useful tutorial, and I hope you enjoyed it, and I hope you'll give StormCrawler a try. And yeah, it works really well with Elasticsearch. One thing I almost forgot. Gosh, this is very professional, all this. If you go into so there's a lot more metrics you could display. So all the components generate their own sort of metrics. So you could add more stuff. Also, there is the Storm system metrics, which are useful to show the JVM heap and such like. One thing we haven't looked at all is the index containing our documents, really. So the stuff we actually do crawl for. So we got 17,000 documents. We can try just a few URLs and with the title and so on. You can look at the JSON, and then you can play. You can do you can try queries like this just for as a matter of discovering. It's a good way, again, it's a good way of spotting problems with the crawl and so on. Great, thank you very much for your time, and happy crawling. Bye.